piece of our presentation is going to be on some other contexts in which we can teach our curriculum. The next one being what a lot of you are probably familiar with on the new GED, which is depth of knowledge. So, for those of you who are unfamiliar with depth of knowledge is what replaced Bloom's taxonomy as kind of a way of categorizing critical thinking skills on the new test. So it was created, just a little background, it was created in 1997 by Norman Webb. I apologize, this text looked a lot bigger on my computer screen. But as a way to analyze the level of complexity or depth of understanding required to perform certain tasks. And it was actually, what's cool about depth of knowledge, it was actually created for math. They eventually expanded it to talk about all the subjects, but it was created by a mathematician for math. So it's really applicable to what we're doing in our classes. It has 4 levels. And like I said earlier, it's about complexity, so even a level 1 problem can be very difficult in terms of the level of math that they're doing, but it might not be complex. And we'll see a little bit of what that looks like as we go through the problems. So, level 1. Can somebody tell me what a level 1 problem is? Recall, Janice says, exactly. Level 1 is recall and reproduction. So in a level 1 problem, you're asked to recall a fact or information or procedure, but it's not just remembering, it's also applying. So level 1 goes beyond just remembering what diameter is or remembering what the formula of circumference is to applying it in a straightforward manner. Level 1 is typically a 1-step problem. It's a well-defined problem, and it's a routine problem, something that you might see pretty commonly. And an example down here asks, which diagram below best shows a rotation of the pre-image to the image? In terms of difficulty, you wouldn't ask a first grader to do this problem because they don't know what rotation is. They don't know what pre-image means. So it's a harder problem, but it's not a complex problem because all it requires them to do is remember the definition and then apply it in a straightforward way to the problem. So level 2. Can somebody tell me what they know about level 2? If not, I can just take it. Denise says skills and concepts.
You have to apply the rules.
Yeah, exactly. So it's taking that remembered information but applying it in a non-routine way. So the first level is applying it in a very routine way. This one takes it a step beyond. It's usually a 2-step problem. It might be in a context different than where it was learned. And it requires the students to make a decision about how they're going to approach the problem. There's not just one way of solving it. There might be more than one way. An example down here, this is very silly when I chose a problem with a whole lot of text as the example. So. But it's essentially a problem that uses measurement and recognizing a pattern, but it's not necessarily a routine pattern where it's just +2, +2, +2 every time, like the one we talked about earlier. It's a pattern where there's 3 inches at the end and then 5 inches in between every peg. And so they have to use that kind of additional step to figure out what the answer is. Level 3, we go a little bit beyond into what we call strategic thinking, which requires reasoning, developing a plan, or a sequence of steps. It often has analysis or evaluation. Sometimes it can have more than one possible answer. A lot of level 3 problems will require you to justify your answer. So it's not just choosing a multiple choice or a fill in the blank or a drop-down option, but they ask you why. And that's not for all of them. There can be a level 3 problem that doesn't ask you to justify, but if you see somebody asking you to justify your reasoning, it's likely a level 3 problem. And then you can see down here we have a problem, again with a lot of text, I'm so sorry, with the systems of equations. I wasn't thinking logically when I made these slides. Where they give you the parameters, and they give you what you need to solve the problem, but you have to do a lot of thinking around how you make a plan to solve it. So they give you an equation and you have to construct a grid. They have to write an equation, go a little bit beyond, where they modify the conditions and then graph and label the equation. They have to determine the number based on, like using the equation based on given information. And then the kicker is explaining how they arrived and justifying their answer. So that would be an example of a level 3 problem, which is strategic thinking. And Jake, we're getting into that worksheet that you asked about earlier, where you asked about strategic versus extended reasoning. And then last but not least is our level 4 problem, where it requires investigation, time to think, and processing multiple conditions. This type of problem often takes the form of a research project or a longer term project. Although I want to caution that the time itself does not make a problem a level 4 problem. You could have a problem where you're asking students to take the temperature every day for 2 weeks, which is a long-term problem, and then they graph it. But that's not level 4, because they're not investigating, they're not using higher level reasoning things, they're just taking the temperature every day. So the length of time is a part of the extended thinking, but it's not what defines an extended thinking problem. And then the example here is, again, a lot of text, where the students are asked to design a blueprint of a house with a given volume, 4,000 cubic feet, that contains the following rooms, but they're given a lot of leeway in how they, they're given a lot of leeway in how they do the size of the rooms and how they approach that. And then there's another piece where they have an approved budget and they have quotes from different organizations. And they have to research the price of the materials. And so it involves a lot of decision making, a lot of planning, and it requires them to do some research into the solution.
Can you send me that?
Yeah,
Please.
definitely. I do a lot of project-based problems in my class, so I can get a little complicated sometimes. But my students really like them, because they feel like, when they're using discovery and really struggling to find the answer.
They feel challenged.
They feel challenged.
Like a challenge.
When you say in service area, you mean service area, you mean floor space?
I probably mean floor space. I was thinking surface area because of the problem we used earlier, but floor space. Thank you. Thank you. Thank you. Yeah. Thank you, Paul. All right. So those are the four levels of depth of knowledge. It goes from the basic recall and application of a straightforward algorithm or formula to a more complicated two-step problem where you might be using a non-routine context, to the problem where they're asked to justify their thinking and they make a plan and they choose between several different options for solving. And then this one, which requires processing several sources of information, maybe some research, some investigation, and really high-level, longer-term planning.
Is this something you made up, or is this something you got from another resource?
I made this up.
You made this one
The
up?
other ones, as you
I
can
was
tell
gonna say,
from my type.
I wanted to research where you find these type of problems. Because I really enjoy when they, again, real-life application.
Yeah. So actually, the next activity that we're going to do is full of problems that I stole.
Yeah.
So I
That's what I mean.
can send you guys the source of where I stole these. These are actually all problems that were developed by Norman Webb, who was the creator of depth of knowledge. Because I did not want to create a ton of different word problems. That would take a lot of work.